big thing for today is this page and U-bounds. Bounds. Huh? What am I talking about? Bounds. Definite integrals have bounds. Wait, we've been doing integrals this whole section. Oh, but what kinds of integrals were we doing? Let's see. Indefinite. No bounds.
Catholic Christian.
Whoa. How did we go there? Almonds or almonds? Normal people or Mrs. Regan? That's the question. Mrs. Regan calls them almonds. Huh? 7. I'm going to zoom in. I'm going to start playing. Feel free to keep collaborating. I'm just playing. Ooh. Ooh, hold on. That's messy. Do you guys find any integration on crack? It happens. It was a little squishy. I'm sorry, Abby. It was a little squishy, I know. One answer's up. Two answers are up. Three answers are up. I know. If you put a 9, you could still get it right? Just if your original problem had a 9, then make it a 9, make it a 9, make it a 9. That's okay. How we doing? Besides the sneaky 7 that looks like a 9. We doing okay? So who is you in the next one? 5 dx. Ooh, that was close. Who's the arrangement, right? Plugging in sine of u times y, or what am I going to pull outside? A 1 over 5. Good. Remember, common mistake. Dividing by 5, multiplying by 1/5. I know it's silly, but our brains do it. What's the integral of sine? Good. Negative cosine. What's the last step? So cosine of what? Let's see. 4 answers are up. No integration on crack yet. But it's not really that crazy. You just have to play around with the substitution more anyway. I forgot I was color coding. I got distracted.
Thank you.
You're welcome. Yeah, sounds good. Bye, Kylie. All right. What is your U? Yeah, good. X plus 3. What's du? So when we plug in, we have a x over u times which of these is not like the other? Who doesn't belong? The x. Oh, it's okay. It's okay. Over here there was an over 5 we didn't like. We just pulled it out. Pull them out. It's not a constant. Totally illegal. Yeah, no, no, no. So, John, what were you thinking? Come up here and say, if u is x plus 3, that means x is u minus 3. How on earth did that make anything better? Split it up, rewrite. Wasn't there a test problem similar to this? X to the 4th minus x squared? No, x to the 4th minus x cubed, all over x squared? The only way to properly integrate it was by distributing the division. One way of doing it is distributing the division. Another way is making it u to the negative 1 and distributing. Another way is making this, an understood 1 over u, like 1 over 5. Bringing the 1 over u up and saying boop, boop. Either way, u over u ends up being 1. Minus, well, I guess you could split it up this way if it helps some of you. 1 du minus, you could pull out the 3 integral of 1 over u du. What's the integral of 1? Du. In period 1, the first answer I got was x. Normally, if it's dx, not dx, it's du. Who has the derivative of 1 over u? Written a forever card on it, not really. But we will next section, because the whole next section is logarithmic integration. Oh, you'll be fine. But if that's true, hold on, not done yet. What do we have to do? Would you guys have been able to make it match? You ready? The final answer would be x plus ln of 1 over x plus 3 cubed but what happened when you plugged in? It won't look like that. What would it have looked like before? How is that possible? Okay, good. Logarithms say if there's a number being multiplied in front, it can become an exponent. So x plus 3 could have been raised to the negative 3. Raised to the 3rd, that's cubed, negative, that pops it down in the denominator. But what else went wonky? What else went weird? What? You can just disappear? Lorenzo, what are you saying? What do you mean the plus c? Good. C is a constant, 3 is a constant. What do we always do when we're trying to simplify? Combine like terms. So what's c plus 3? I don't know. A new c? Oh. So is this c and this c, are they technically different c's? Yep. You can make this like a c1, you can make this like a c2, but either way, arbitrary constant plus 3 would just be some new arbitrary constant. Something. That kind of makes sense. Constant plus a constant is a new constant. So what's going on down here with creative math? Pause before we do that. Any quick questions on any of the integrals that I solved up above? Sorry, I meant to pause and wait. Anybody get lost in a step or in a process? Why did I do what I did? We're okay? All right. So I'm going down. Careful division. Hey, we just did division, and which one? The last one, yeah, we did division. We did splitting up division. So that's one way to divide. Technically, we could say careful multiplication and division. But what other kinds of division are there? Synthetic division. Long division. Rational functions. Question: how would you integrate the following? Integrate. I heard synthetic division. I heard factoring. Probably right. Synthetic division. What were you thinking, Lainey? First person I heard. What would go in the box? And I'd have 2, and I'd have 6, and I'd have 4. I'd bring down the 2. But what does that tell me? The answer to the integral? No way, Jose. Not even close. But what does it tell me?
2x plus 4.
Simplifying, this divided by that actually can be rewritten as the integral of 2x plus 4. Impossible to... Hold on. Someone else said long division. How would that have worked? How does long division work? 2x. Then I have to distribute, right? Then what? Good. Negative. We have to subtract its division. 2 minus 2. 6 minus 2. Last year I would have been like, distribute the negative. Don't kill a seal. Hopefully you won't. With that. So when I divide those two, that's what's... Oh, so I could really just solve 2x plus 4? Colby. Be factoring more, yeah? What'd you get? X plus? Be the same thing? Yeah. 2x plus 4, 2x plus 4, 2x plus 4. Hey, that's division. And it's not just division like we saw up above, where it's like, hey, split up 2 different terms because we can't have, or we can't do division in an integral. We're right. There's no quotient rule for integration. But, well, that one after u sub. Oh, this one I can split up. I can split up divide by u, divide by u. This one, divide by x plus 3, divide by... Doesn't help. This way, division helps. Up on the board, division helps, whether you thought of synthetic or long or factoring. But is that the only kind of division? Or the only time division is helpful? What if I was to give you this one? Ready? Ready to have your brain stretch just a little bit? Now what? Synthetic. Nope. It's a squared. Well, it could be an x plus 1 or an x minus 1. Long division. Do you remember when we saw these last year? Improper functions that we had to divide first before? You will remember if you don't right now. It's an improper function. The top is bigger than the bottom, so therefore we should divide. But what kind of division? Long division. Because long division is the only one that allows me to divide by something other than a linear factor. Synthetic says, no, 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 only an x minus a or a 2x plus 3. Has to be a linear factor. Factoring, well, you have to see it. Who wants to go factoring that cubic? Not me. But what happens when we, guys, what should I put? X squared goes into, oh, I should put a 0, x squared. That's true, just to be safe. I agree. No, yeah, it is good. It is good. Plus 1? Okay. Sorry, now what? Good. Then I get minus x, right? Would you have killed the seal? That's just 0 anyway. Negative 2 minus negative 1 is negative 1, true? How many times is he going to him? No, because the powers, right? He's too small. No, negative 1 won't work with negative x. Negative x squared. But now it's improper. Or now it's, I should say, fraction. Better to say, no, no more wholes can go into parts. That could go into that one because we had a degree discrepancy in the sense of top heavy. There's a whole part, there's a whole component in here. But Gavin, as soon as you're thinking x to the negative 1, that's a fractional part. Stop. Make it instead a fraction. Negative x plus 1 all over x squared minus 1. Oh, of course I chose one like that. It wasn't supposed to work out that nicely. Hold on. Pause, pause, pause. This, this one at this point, do you guys see that you could pull out a negative and then x plus 1, x minus 1, and then simplify? All right. What if I was to make this 2? Now, how are we doing? Bad. Doesn't factor. But hold on. Can't we rewrite this to be this? The integral of, do I like x? Oh, I love x. That's 1/2 x squared. I know him. I had no clue what to do with him. U sub, yeah, but du is 2x. Right? I don't mind x. I know his integral. Oh, what am I going to do with this guy, though? 2 minus x all over x squared minus 1? Can anybody think of any other math that lets me break down something complicated into smaller pieces? You're thinking calculus. Think pre-cal. You're thinking of breaking down into like f's and g's. That's good, but those are compositions of functions. I don't really have a composition. I mean, I could, but u sub isn't a good idea. No? Good idea. You're being creative. What allows me to take a fraction, a nasty fraction, and break them down? Couldn't x squared minus 1 be x plus 1 times x minus 1? Was there something a long time ago in pre-cal that we did that honors pre-cal just went over? Starts with a P and ends with the partial fractions? What? That's a CalcBC thing, don't worry. I mean, you guys should be able to do it. Can anybody see, though, why it would be nice if we could get a constant and a constant and split this guy up that looks like this, and we're like, u sub, 2x. Why is this better? If you find the a and find the b, which we should be able to do if we reviewed partial fractions, guys, that's a constant, that's a constant. Who could I make u? I mean, I know him, 1/2 x squared. Him, make that u for this little part of the integral. What's his du? Oh, so a comes out 1 over u du. You guys already told me that's ln. I got him. I'm good. How about him? Could he have another u? Remember, take them one at a time. Zoom, zoom, zoom. He has his own u. Constant comes out 1 over u du. Ah! Impossible. More possible. Totally possible. Yeah. Yeah. Partial fractions, pre-cal, it applies. So what am I talking about when I say careful division? I don't know. I could be talking about all sorts of things. Could be talking about division. Let's just put it this way. I could be talking about splitting up division. Splitting up denominators. What is that? Like the one up above. Like the one on the test. X squared, or sorry, x to the 4th minus x cubed over x squared. Could be splitting up a denominator. Taking a division and saying, no, I need addition and subtraction. It could be simplifying rational equations, which is like the one that I just showed on the board, where my numerator could factor out and cancel the denominator. I could take away, in essence, the vertical asymptote. I apologize. I could take out the whole, and I could actually solve. Or it could be improper functions, aka fractions. Man, all of those would need some sort of division somewhere along the line. What's the second creative tip or trick? Colby, that could be like your conjugate idea. Like if you had a nasty 5 plus square root of x squared minus 1, maybe you could multiply top and bottom by a conjugate, change it up. Maybe it would help, maybe it wouldn't. But that is an idea we've seen before with limits that seem to help sometimes. Multiplying by 1 creatively. We haven't seen complex numbers this year, but that was pretty important for simplifying complex numbers too last year. Substituting with trig identities. Bonus on the test, anybody? Part 1. Remember that big old trig expression? And it wasn't an exact rule as it was stated. But if you did some, wait a minute, what forever card had trig identities? Some of you need to look at that card again. Adding by 0 creatively. Ooh, you guys want to see an example of this one? A BC example of adding by 0 creatively? Actually, it might not even be a BC example. What if I was to give you something like, oh, in period 1, I was able to do this. I didn't do an example like it. Okay, what if I gave you something like this? Factor, sure, nothing cancels. Oh. U sub, who would you be? The denominator, right? Isn't that the innermost? All right, some of you seeing why it's a little sad if the bottom is the denominator? And this problem would actually be super frustrating? Why is this problem super frustrating? Oh, right? If only. Adding by 0 creatively. If only. Nope, illegal. I can add by 0. What does it do? I'm just showing you bits and pieces of Calc BC's more integration chapter. Am I wrong? No. 2x minus 4 is 2x minus 5 plus 1. I'm right. Why did I do that? How am I going to solve this part? Using U sub. Why? It's gorgeous. It's ready to go. How am I going to solve this part? You guys actually want to see what I would do? It might be an impossible one. Yeah, I am going to complete the square. 5 over 2, 25 over 4. Which would be, what, x minus 5 halves squared minus 16 fourths? I wish I had done this problem a little bit different. You would need to do trig sub, which sadly, I'm not going to be able to show you trig sub today. But anyway, and CalcBC only barely knows it because they don't really need to know it for the AP test, but they've done it a little bit. Anyway, yeah, it's at least more possible than it was before. Sorry, I should have done something like, I don't even know what. Plus 10, that would have been nicer. Let me show you plus 10, that's more fun. That's something that's at least you might possibly see at some point. Aha. What's 10 minus 25 fourths? 40 fourths minus 25 fourths, 15 fourths, right? Perfect. We're good. What? Does anybody have their forever cards close? Can you go find for me the derivative of tangent inverse of u? Do you know that we can always take a u squared plus an a squared in an integral and get back to a tangent? Don't worry, that's not for 2 sections. Anyway, cool kids. Long story short, adding by 0 creatively can be quite nice. The sad thing is, when you make something match and be perfect, you've just added something extra that you have to deal with off to the side. But either way, all of these are really cool creative math tricks. But that wasn't actually the entire point of today, even though, I don't know, you guys are fun. I like to stretch your brains. The entire point of today is finishing section 4.5, which part of it was putting together all the integration stuff we've done up until this point with indefinite integrals. But what else did I say we had to cover? Definite integral. So here we go. Definite integrals. U sub indefinite integrals. What if there are bounds? Loves to make sure you know what to do with bounds and U sub. He loves to make sure you know what to do with bounds and U sub. And they force your hand by not giving you functions and giving you clues and making sure you know what's legal and what's not. Little stinkers. Some of you have realized what I'm talking about when I say things like they're not going to give you functions, they're going to give you clues, they're going to name guides like F and G, they're going to give you tables of values, but they're going to force your hand to not be able to solve it as though it was a word problem or a homework problem. Without a function, you can't anti-derive. You have to know the process, procedure, the rules. Anyway, U sub indefinite integrals. What if there are bounds? Solve definite integrals with U sub without changing it back in terms of x, or when unable to change it back into terms of x. Like the AP doesn't give you the function, you don't actually know what the x's really are. Main idea, change variables, you gotta change the bounds. Do you guys see below on the left-hand side, isn't everybody in terms of x? The f of g of x, the u prime is in terms of x, the d is in terms of x. So what do you think a and b are? Yeah. You guys know that from the area concept, don't you? From x equals a to x equals b, we were cutting off regions, areas from one x value to another. That a and b are x's just like the function was in terms and just like the differential was in terms. So struggle. If you substitute in and get du's, if you substitute in and somehow get everybody in terms of u's, guess what you also have to do? Got it. Here's a sad thing. What if it's a definite integral and you did perfect u substitution and then you went ahead and anti-derived perfectly and then you went back in terms of x's and you plugged in the x bounds perfectly and your answer is perfect. But you wrote the integral with u's and x bounds. What are those AP guys going to do? They're not going to take away everything, but they are going to. That's incorrect. You cannot solve a definite integral in terms of u with x bounds. It's not possible. Or I shouldn't say it's not possible. It's not precise. It's not perfect. There's a hole in your argument. We've talked about that earlier this year. So, all that to say, what do we do with u bounds? What do we do with definite integrals? How do we show it? I have two different options, and both of them are good. But both of them you can mess up, and I could steal your points, even if you totally get the correct answer at the end. So, ready? Here's one. What if I give you the definite integral from -1 to 4 of 5 minus 2x to the 8th dx? How do you show me work in a way that you don't lose points? How do you show me work in a proper way? Well, here's the dealio. We actually have a little bit of work to do before we even go to the two different methods or the two different ways. One says never change the bounds. The other says, nope, you got to change the bounds. So how do we do that? Who's your you, guys? You're totally right. I didn't even give you a hard one. Tangent inverse with really nasty sub. If you're really curious and really bored, you can check out how to actually solve it. Anyway, yeah, we didn't have time to finish them very well. It's kind of sad. We're supposed to watch the video. Coming back, who's your you? And dx over -2. So I don't care. I'm just going. But now, when I go to plug in, just making sure everything works out, there's my u to the 8th, here's my du over -2. Now what? Okay, we can, why? Who are you? Go away. So coming back, adds. Now it's time. A road diverged in the yellow wood. Two roads diverged in the yellow wood. I chose the one less traveled. It's made all the difference. Anyway, you can go two different ways. Both ways will be fine, though, in this case, as long as you don't make the mistakes on either one. One says, okay, you go to rewrite, and you never write the bounds. So you pull out the -1/2, and you do the integral of u to the 8th du. But instead of writing -1 to 4, which would be incorrect, and you could not actually integrate as far as properly with x bounds in a u expression, you could say 4 x within -1 to 4. There you go. You have the meaning. You have the -1 to the 4. You know it's supposed to be a definite integral. You're just not putting it there because it's illegal. And then you go ahead and say, all right, cool. So I have my -1/2. I have my u to the 9th over 9, or 1/9 u to the 9, 4, x between -1 to 4. And then you can go ahead and say -1/18 times, now plug in your expression in terms of x's, 5 minus 2x all to the 9th. Now I can, I'm back in x's. Yay, I can bring them back. And then, solve. You would end up with, what would I end up with? Let's see, -1/18. Let's forget the dots. Let's just solve it. -1/18 times, I'm just going to do FTC, like -1/18 has been pulled out of f of b minus f of a. 2 times 4 is 8. 5 minus 8 is -3. -3 to the 9th is negative, because an odd power negative just ends up being -3 to the 9th. And then I have minus, let's see, -2 times a -1 is a +2, 5, that's 7, and 7 to the 9th, so minus 7 to the 9th. I guess I could be really snazzy and pull out that negative and make it 1/18. 3 to the 9th minus 7 to the 9th, but that's good enough for me. Done. What's the other way? Very similar, just a little bit different. The other way says, when